Okay, we can start. My name is Juan Quintela, and I am going to talk about migration. So, what we have done during the last year to try to make migration more robust. So, we start going there. We are going to talk about a couple of things. What we have done, what are we going to do, and anything else that you need, you can also complain. Then we will see, we will do anything about that, but we can try. So, we are going with Omar, starting with several things. One of them is that one of in the Google Summer of Code projects, we have 2 projects down there. We have 1 project, but he did 2 things. He was one improvement about the project that he decided, that is Bitmap Logging. Right now, we can do when we are running a guest, we don't know how much memory it is dirty. So we have exactly that infrastructure that is what we use for live migration. So we can use that just to know this. What we want to do that? Well, if we want to analyze what pages are used one application or one operating system in this case, we can. And we can try to start doing things like calculating how much would take to migrate this machine. Why? Because we can, if the load is more or less stable, and we can calculate how many pages it is dirtying, we can calculate the maximum downtime or something like that. Notice that this is estimations, but this is one improvement. So this is one of the things. The other thing was that we were not able, we didn't have one easy way to test device. When we are doing migration, we have 2 things, run and devices. Run is normally a lot of run, and if we commit one error doing migration of the run, we notice very, very fast. Why? Because it is in the middle. And there is other thing, that is the devices. Problem, right now the devices are only checked after we do the migration. And sometimes there are special cases, and we are failing in special cases. VMState continuous testing, what it does basically is it stops the machine, it dumps all the device state to a buffer, reset all the devices, and reload for that buffer all the devices. And it does that in a loop running the guest. So we are able to, without doing a migration, we're able to test in a lot of situations what is happening there. This is basically what we do here, what I have just described. And this is basically problems here. As usual, the problems is in the details. Notice that this is, I am describing the thing that are posted upstream. Not everything is still implemented, except for this one, that is Amit do one migration checker. And what is a migration checker? Okay, right now, to know if one QEMU is going to be able to migrate to another QEMU, notice that there is 2 things that we want to check here. That we are able to migrate because it has the same devices and because the devices are on the same versions. Well, this is what the migration checker does. He presented that last year, but it was integrated this year, and it was integrated in QEMU, how to build, how to detect these kind of things. Notice that one that we are doing the comparison, it has some heuristics to notice if 2 things are the same, even if it has changed names or something like that. It has been proven things. Other thing that we didn't have is that all the communication during the migration channel is doing in the clear, I know. And the second thing is that we don't check what we read. Yes, I know also, it's very bad. So the problem is that until now there was nothing that can be done. So while Michael Sirkin was doing efficiency and CVS, he added one thing, that is VMState validated. This is the equivalent of one assert. You can call while you are reading data or writing data, you can get this value, and you call this function, and with this function you see to check if the value is valid. Why does it matter? Why? Sometimes we read for the network something like the size of one buffer, and then we read the size. If we are not checking what is the size that we are reading, well, we can overwrite anything. So this is one of the things that we have done. And we also implemented VMState testing. The patches have been upstream and have been on the list, and we are integrated few of them. This was done by me. What is here? Basically, if you wanted to test how VMState worked, or is something, how to check when you, in VMState there are some things very easy, that is when you have one integer or something very easy, but sometimes you have one pointer, one structure, that is one array that is of pointers. So testing that was very difficult, and the only way to do that until now was you create one device, you create that structure, and you try to migrate. You file it, and you have to start from the beginning to see what was happening. Well, with this, we tested all the macros, and not only tested all the macros that are in VMState. You can do, if you are testing, okay, how can I migrate this? You go to that file, that is one test, and you see how it was there. While doing that, we did one simplification. People think, okay, do you call this one simplification? There was more than 2,500 insertions and almost 1,000 deletions. Okay, the problem was this. Almost all the insertion was in the test. We have no test, now we have a lot of tests. So they were all there. This is basically what we wanted, we have done. If you have any question, you can ask from here at any moment. So this is the more interesting part, that is to continue making it more robust. What are we going to do from here? So something like that. One is generative fields. Just now, the field that we are migrating needs to be in the state. The problem is that the state modified for any reason. They decided to optimize, to do something like that. And each time that what we put in the while is not one field in the structure, we need to do magic. So this was one of the things that was here, that if you see here, we create a new way to write one value and a new way to read one value. This is a very, very bad idea. Why? Because if we do things this way, if we try to change the format, write to a buffering something, we need to go to all these places that have one generative field and change there. But if you think here, this is really one int 64 value. So what we want here is to split that function in two functionalities. One is get from I don't know where in this buffer 64 bits, and now for this 64 bits from this buffer, write it to the channel, and the opposite. So the idea is to split this. So we will move something like the first one. This is how we put one integer. Okay, we are moving to something like this. This is not the API that needs to be, but this is int64 generated, and we have the same fields that before. And we added one read and write. This is read this way, this is write this other way. And this is also interesting because we can reduce the things that we have in the other side. Things like, for instance, VMState uint8 equal. This was that we read one integer of 8 bits, and we look that it is the same that it was in the structure. This is completely trivial to do. In the read and in the write, we can put the file that you read it somewhere and you check that it is the same. What this is important? Okay, we reduce a lot of macros, or we can write them on top of this. And things like VMState revalidate, this is basically what we wanted. That is, when we read one value, we want to make sure that it is consistent with what we want. So we can have less fields. Having less structure is good in the sense that as we have the same number of bugs independent of size, if the size is smaller, we have less bugs. So not doing the same is something like that. Mike Roth is here, so he knows something about this. It's basically now our email interface, we have during the all QEMU code like this. QEMU put 64 bits Vikendian in one QEMU file. We don't need that. We can have something as simple as having one opaque just put BA64, and we will initialize that okay, and the operation that we are using somewhere else. And we don't care then if we change the implementation from QEMU file to a buffer, is valid. We change to a new format, is valid. We don't need to move everywhere. You just see there is two things that we are saying here. We are using QEMU file, and we want to put in the station migration 64 bits. The only thing that we need to put in the whole code through all QEMU except in the migration files is we are writing one 64 bytes value. For the rest, we don't care. We will do somewhere else, and this is one QEMU file. We don't care what a QEMU file is. Sorry. No, whereas this is something but was merged. My rook did something similar, moving to visitors. It's not exactly this because there was another thing, that is how we generate VMState. And he was doing that. He was able to, from the struct state of one device, was able to create the VMState, but then we have to put back the version. So it did several things, but one of the things that it did, that series of patches, was something like this. It's not exactly like this. It's not exactly like this, but you can merge to do something similar. Well, here the problem is that you can put your format here. Everybody wants to change the format. The format didn't matter, really. The problem here is that we have one big problem, that is what we put in the stream, in the migration format, in the wire, and what we read from the wire. We are not, for instance, we are not sending the metadata. It will be much, much more useful just to put a metadata there. Because then we get, okay, the way to interpret what comes after this is to have this metadata. You can read it. And things like that. There are patches anywhere to put ASN1. The big problem right now with the format, that this is what I want. The previous series is that just now changing the format is basically impossible. Because or you change QEMU file inside of the QEMU file implementation to do something different, or you need to go through the whole tree. Both things are not feasible. So once that we move it to the previous thing, experimenting with new format, adding feature, whatever is easy. Once that you make experiment easy, we expect to get nice things here. So this is optimization. Take what I am always asked about optional exceptions. Just now we can send small subsections. Subsections can be there or not, and we have a function to check if they are there. We didn't have that for whole sections. This is a bit complicated, especially when we want to maintain the migration stress. So I hope that you have posted this buffer. I posted it upstream this morning. I agree with that, so probably nobody has seen it. And what is here with the optional exceptions? What we want here, for instance, the sample that I put there. The sample that I put here con optional exception. Right now, when we start QEMU in the target machine, we can start it in two states, running or with -s that is paused. There is no other way. So the optimal way, the fast path, is basically you run the target machine, the target QEMU running. So you start the QEMU, you start the migration, and when the migration finishes, the target detects that it has finished and it runs pretty fast. The problem is that if while the migration is happening, it appears one I/O error or any kind of error, source moves from running to I/O error. We have had one problem, but migration continues because that is independent of the migration. And when the migration arrives to the other side, they say, I have finished migration, I can run, and this thing is something, If you have one I/O error in the other side, normally what you are going to get is corruption, this corruption, if it is related with this. So this is something that I added. I added one field. Another of the things that people are not completely happy about, that is, there is a new section that is what is the state that QEMU has. So when it arrives to the destination, in the destination it reads the state, and the state, if it was running, I put it running. If it is I/O error, I put it in I/O error. I mean, it's so difficult than that. Problem is that, is this guest visible? Some people think yes, some people think no. Say something. I expect some discussion about this. Okay, but if you think about this, this is a new section. I told that this inside the optional section. What happens here? This is something that is usually happening here. We can add this section for the new QEMU, QEMU 2.2, 2.3, I mean, if it don't enter this cycle, it's the same. The problem is that if we're migrating with QEMU 2.3 with machine type PC 2.2, and we migrate to a QEMU 2.2, and we send this new section, it is going to say, no, I don't understand that, and it fails. So we want to not send it to 2.2. We can put that we create that option only if we are in 2.3. False. Because if there is one I/O error, we want the section to be sent. So that you say, I don't understand this section, I abort. And it's the right thing to do. It just say we cannot go to the past and change the other QEMU, the old one. So if the section is optional, we get several things. That is, new to new, work correctly. New to old, do exactly what we want. If there is no errors, setting is not sent, everything goes well. If there is one error, setting is sent, and everything is break. Old to old, it happens like old to old. But there is other thing, that is, if we have in one thing that is QEMU 2.3 minus machine type PC 2.2, and we migrate to QEMU 2.3 machine type 2.2, if we send the section for, with one error, it understands it, even if it is in one running with one machine. So this was basically what I was thinking to discuss about this. And then one last thing related with what we have done. Intervention migration. Until now, we have done completely wrong, in my opinion. Why? Because we have allowed anything to anything. Anything to anything is basically has never worked well, because we changed the layouts of memory, we changed the default options for devices, whatever. So my proposal for that is that currently we have this QEMU old minus MPC to QEMU minus MPC. Then we pray and we hope that this works. But what we are telling basically is QEMU 2.1 minus MPC 2.1 to QEMU 2.2 minus MPC 2.2. If you think about that, they are two different machines, and they are not going to work. So my idea, or it could even be something like this. The problem is that we don't know, really. Fixing this is as easy that we only allow this. PC 2.1, the machine type needs to always be the same. We send the machine type in the migration type at the beginning. And when it arrives to the other side, if it is the same, I try to continue with the migration. If it is not the same, not even try. And we have some experience here that is basically what we have done with Red Hat, with RHEL. This is basically, we only allow migration from the same, not the same. QEMU can be a different QEMU binary, QEMU version or whatever. But if we migrate from one to the other, it is with exactly the same machine type. Why is this important? Because we can test. Now we can test if we are really working. We run from QEMU 2.0 to QEMU 2.2 with the machine type PC 2.0. This is testable. And there is other thing that if we find one problem, we can always fix. The worst possible case is that we have to ship the two devices, the one that was in PC 2.0 and the one that is in PC 2.2. This basically has never happened to us, I mean in practice, but we have a last resource chance. Right now, this is basically, we cannot fix it. And in consequence, we are telling that this is going to work in upstream. The previous one, that minus PC from the last version is going to work. It works sometimes only, and we never detect when there are problems. So this is something that can work, and we can make, because we can make changes in the machine type PC 2.0 in QEMU 2.2 to make it work. So that was basically what I wanted to talk. Anything else that you wanted to talk about? Yes.
You're right about the machine types, but I think we could just extend that to most command line options. I mean, it's not just machine.
Yes, but my idea there is that I can put one machine option, I can put one machine type. For me, it will be the first section that we send, and then we can add things there. The problem here is that, for instance, in an ideal world, we should be able to create one machine from inside QEMU. From migration point of view, it will be perfect that we just run in destination QEMU, IPEN, incoming, TCP, whatever. We connect to there, and the source says, OK, my current machine is this, PC 2.1. Create one PC 2.1 with so many memory with this thing. The problem is that QEMU don't have that ability, and it's not going to have it. If I put this, my idea right now is put that there. The command line options that I can put there as optional sections, and I can add sections in the future as more things can be added there. Right now they can be, but I can try in the future. So this was my idea to fix that problem. More comments?
So, are you aware of any guest visible changes that depend on build time options? I mean, to make sure you have binaries that are really exposed to the same API, or are we good now? Are there defaults that people choose a build time that will make the machine different?
This is other of the things, but this is not related to this. That is, I was thinking about creating migration tainted. This is something that right now some things are in VMState, but even being in VMState, the size that we declare that they are sending is not the same that we are sending. So this is the only cases where we can get out of sync. The basic device minus 11 is not in destination. We get out of sync only when we change sizes. So we can really put that time the value that we can count. VMState says that the next field is going to be 16 bytes, but it was 18. So we tainted it and say, OK, something wrong happened here. I don't know what. Normally it works, because normally it works, but this is something like, please fix this.
I'm thinking about stuff that may be completely outside VMState that change at build time. I mean, some device configuration about what's the default.
Yes, this is the other thing that is, for instance, right now data pair has multi-queue. This is one problem related with when we run with machine, for instance, QEMU 2.2 with PC 2.0. There is no way, in general, to say to the IDE, the driver, please run like in 2.0. There is some options, only some options, but we don't know, really. I mean, there is not one generic way of telling, please. For instance, for the migration protocol, even as it is today, it is really trivial to fix that. Same things like in the version 4. It will change just one while the interpreter to use also the versions in the source. When we are sending, we are not using it, but we could do. But the problem is everything else. That is, I mean, not every device is able to do this. Why is this important? Because if you care about backward compatibility, you fix your device. If you don't care, okay, it works as now with the last versions only. Amit, you asked something? Okay, any other question? This was it. So thank you very much for everybody for joining. Thank you.